first, right? As mentioned, insert, right? Existing products. Let me label. I insert base first. See, you have base here, right? As usual. Normally, I try to fix one of them, this base first, right? In assembly, right? This one, assembly. Fix this one. Fix what? I want to fix this one. Okay, so this one is already fixed. Next, I'll bring in another one is sliding wedge. Sliding wedge, right? This one is existing product. Sliding wedge with this one. This. Okay, so we have this one. Just want to move this one up a little bit. Okay. So you have this one. I want to actually assign prismatic joint for this one. Okay. Look at this one. I can do prismatic joint because this one is sliding along this one, right? Right, sliding along this one. And look at this one. If you look in the dimension, I mean the detail of the part, you know that the distance between this and this plane is 1 millimeter, 2 millimeter over this one, and this one. So you need to do offset between this and this anyway. Okay? And as well as this space and this space will be coincident, right? For these two parts, you will want to create a prismatic joint. You can use this template, cylindrical brick. Yeah, you can use this template if you want, or if you go inside this one, right? Inside this, you can also use this template. Yeah, prismatic joint, right? This one. If you look at this one, if you use this template, you know, they ask you which format you're going to use, right? In this case, in our case, you have to use, you see, offset, coincident, right? Look at this one, you have offset and coincident, right? This one. Each one of these you have to choose. They give you 3 options, you see, but you see you have only 2 options. You have two input. So you have to think. They give you. You need to have 3. Let's say I have this one. Let's say I have this one. They argue for 3. One will be control. One will be control. It means that one will be like you add motor in there. In this case, I don't have motor in this case. This is an active. This is a passive joint. So sometimes I don't like it. I mean, for sometimes it's not that productive. I think I do it by myself anyway. In this case, right? I know that it's prismatic in this case, but I want to input. Let's say this offset first between this and this offset, right? And this phase coincident with this phase. Either one can be select first. If you select this coincident phase first, this phase and this phase first, if you set offset between this phase and this phase and this phase, it will be more difficult. ทำยากกว่าเพราะมันติดกันเวลาใช่ป่ะ In this case, I think I will do offset first, right? I do offset this one, offset between this one. The first one will move to the second one, right? I set this one first, select this one. What's the distance? Distance is 1. Okay, distance is 1. Okay, you want to check clash? Yes. Okay, this one. So we have this one. Let's say, if you put it only this, it will be changed to prana. Right? Right? Let me do it again. Let me delete this one. Do again. Okay? Consider, I use offset. See, this is user divide, right? This one and this one, right? 1 millimeter, yes. You see, suddenly it changed to prana, right? This one. Okay, let me have another one. Coincident this one. You can use contact, it's also possible. Coincident this one. I want this one. Coincident with this one. See, automatic change to prismatic joint. You see, and we don't have any control because this is only active joint. If you want to keep the control for this one, it means that the input distance has to be put and in this case this is only this one. Okay, so you have this one. See, prismatic joint in this case. Right, this one. Okay. But this one still can move. Let's say if you have this one, see. Next, the other one is I want to add lifting wedge. Right, lifting wedge. In this case, you see lifting wedge. Insert existing product. Level lifting wedge, this one. Okay, so you have this one. See, this one you have. Look at this one. You have this. You need to know that this one, this hole has to be aligned with this hole. This hole has to be aligned with this hole. And the center in this hole. Then between this part and this part, you need to align this one and this one. But between this one, this lifting wedge and sliding wedge, you have prismatic joint, right? This space and this space and this space offset with this space, right? Okay. So in this case, you need to create two joints. One is between this part and this part. The other one between this and this. Right? So you have to do two joints in this case. Right? Okay. So first of all, I try to align this one with this base first. This one with this base first. Right? Because you remember, right? Joint we connect between two links. This we have 3 links. You see, we have 3 links. So you need to join between this one and this one, and between this one and this one. You have to do twice. Okay. So first of all, I try to align this one with this one first. Okay. Okay. I do have this one. I want to consider this one. Select this one first, and select the bottom of this part. See? Okay, it's changed to cylindrical. That's okay. Now we have this one, cylindrical between this joint and this joint. Right? It's aligned this center and the center of the bottom hole. This one. Okay? Next, I design prismatic joint between this one and this one. Okay? I do the same. Okay, I use different. I just assemble myself. I set offset first between this space, and this space. Okay, 1 millimeter. That's okay. Next, consider between this space and this space, right? Add one more coincidence between this space and this space. Okay? Okay. That's all, right? It's a passive, so we don't have any control joint. Yes. Okay. Okay. Got this one. See? Got this one. The automatic force this circle and this hole to be aligned. See? Aligned. Okay. Some students, some people try to say, did not align this one, did not align this, not align this one with this one. It means that if you not align this one, you can move this one, right? You can move this one. You free to move this one, and you avoid what? Not align that one, but it means that you can move this one, right? So it means that you can avoid coincidence, right? I mean, not coincidence, crash. That's not for assembly. Right? But for real thing, no. The real thing, you have to align this one with this one. In that case, this one can be moved. This one can be moved based on this one. In this case, right? Because the right center, you can move just only this direction. Okay. Right? And this one. Next, I bring another one, alignment plate, right? Okay. It's alignment plate, this one. Okay. In that case, I can do what? This one with this one. Actually, in this one, can be freely to rotate anyway. But for simulation, you have another story anyway. Let me align this one with this one first. Coincident between this one and this space, right? Okay. And also this space and this space will be coincident. See, one more. This space and this space will be coincident. Okay, this one. Okay, it's a level joint, right? Level joint. It means that this one can be rotate this one. But for simulation, sometimes you want to fix this one with this one. If you want to do simulation, you want to fix this one with this one. Otherwise, you have another input here. Okay, but I just leave like this. Yeah, this one. Okay. Next, I'll bring in the screw. Right, this one. This screw. This one. Okay. Screw just like this one. Look at this. You want to check this one, you can go there. And this. See, now we are in part design. See, now we are part design. We are here inside this one. And with this one to escape this one. See, get this one. Inside, I mean in the drawing maybe not that clear, but yeah, just try it anyway. You can modify until you have this one. I don't need to draw this screw here. Yeah, you can do it if you want. Okay. So we can modify any part anyway, if you want. Just go there. And don't forget now, we are in part design. If we finish part modification, you just go back to assembly. You double click this one, right? Double click this. Now you back to assembly. And back to assembly. You have to notice the module that you are using as well. See? This one, I want, let's see, I want this center and this center to be the same. I mean, coincident this one and this one, right? This one. Let's see, I do this one. I use coincident. Select this one first, because the first one we will move to the second one, right? Okay. See, you can let's say I just put this one. Okay, I can modify it anyway. All right. In this case, you can bring this one and move this one, right? See, right. See. Actually, I want this plane. I want this plane to be coincident with this one, right? This plane to be coincident with this one, right? I want to change this one, you see? I want to change this one. I just add, right? Oh, not this one, sorry. Okay. See, this one and this one, I want this plane to be coincident with this one, right? So I do have another one. Let's see. Okay. And okay. Coincident between this one, this plane, and this plane. Right? So you have this one. Okay? So you have this one. This runner. So you have this one. Okay? So in this case, you have, look at this one. For the condition that you just apply, you can move this one. See? But you cannot move this one. You see, if you change this one to this one, nothing happens if you move this one. See? Because you haven't assigned any relation, you see? Yeah, add this one, see? Nothing happened, you see? Right? Because you haven't added any relationship between this one, I mean this rotation and this translation, this one. Okay? Okay? So for assembly, this one is okay. For assembly, this one is okay. Okay. But anyway, for simulation, this is not okay. Not enough. Not enough. Between this part should be okay. Among this part, among this one, you see, look at this. Okay, between this one, it's okay in this case. But this one haven't any relationship between this and this. You move this one, it means that you put this one. If you want to rotate this one, you need to give the relationship between rotation this one and the distance this one, or screw joint in this case. Okay. So far, try it first. Try it until this one first. Okay, let me add. I want to specify screw joint. I want to specify screw joint between this one, this screw, and this sliding wedge. Right? Between this and this. Right? Okay. 1 and 2 as a screw joint. Okay, between this one, these two. So let me add this one. Okay. Look at this. I want to use the template screw joint, in this case the arm of 4, right? See? Offset is a control, right? You see? Offset, this one is a control. So this step between this and this, I will put this one. I put this one. This plane and this plane. This one. See? Okay. Okay. See, we have this offset between this one. This is a control actually. And hinge. Okay. I want this one to be rotated with this one respect to this one. Right, hinge. And use this one and this one. Okay, and the axis will be this one. Okay. You look at this one, it is okay. And compound this one, right? This is a ratio. You have to notice there's a red color here. Red color here means that there is something wrong in that case. You can have this one. You have option here as well. See? And sometimes you have this one angle, this one as well. See, in this case you have this angle, right? Is it possible to do this angle, this one? You see? Or angle this one, or angle this one, right? You see? Change angle. Or the plane that you use, you see? I'm using this bicep. It's better to use bicep similar to, right? I did x, y. Let's say this is x, y. And it maybe sometimes you need to use x, y here instead. See, is this okay or not? You have to change. You have to try this one. You see, right? I will not. I just leave like this one. Okay. Okay. So you have angle. This one. This is an input. Angle input, right? And the other one is this one is offset, distant output, right? Ratio. And this is a coincident. If I want to put this one first, I can do this with the hole there. Okay. Okay. All green. Now look at this one. All green. let's show this one. I want one revolution, 360 degree. The distance may be 10. Let's say distance will be 10 millimeter. Okay. It means that if you rotate one revolution, this one will move 10 millimeter 1 cent. Okay. Okay. This one. Yes. Okay. Okay, so you have that one. Okay. Look at this one. Put it up this one. Okay. And next, you can have this one. See? See? Rotate this one, move, right? If you change 10 to 20, it will move faster. Okay. That's one. Okay. Okay. So once you finish this one, if you want to do simulation, this one is good for assembly, right? You need to go to mechanism system design. Right? First of all, you see, you need to keep the name of the mechanism. Say, first one is this one. We give this one. Okay. First of all, give the mechanism name. Next, check whether your mechanism is ready for simulation, right? Mechanism manager. Like this one. You have 2 input and 1 degree freedom left. In this case, you cannot do it. You need to make this one so that you have 0 degree freedom. Right? 2 input. Let's say I have this screw. Right? There's 2 input there. Right? I want to change to angle. Right? Screw just only one. Just only one. Okay? This one. So let me check whether it's okay or not. Only 1 input now, but still 0. So you need one more condition for this one. You need one more condition for this one. Okay. Okay. I'll just leave for you. One more condition. In this case, you look at this one. We have this, right? This, let's see. Look at this one. This one, you see? Remember? This one and this one, we just align, right? Remember? This one just align, right? It means that this one can be rotated this one. That's why that's another condition. See? You want just this one, just move this direction. But if you set just what? Coincident between this and the hole there, the hole this one. It means that this one can rotate as well. Move this one and can rotate because it's cylindrical. In that case, you need to make this one actually will not rotate. Right? In that case, there are many ways to do it. You can specify this plane the plane of this and the plane of this one is coincident offset, or a side plane of this one and plane of the whole will be offset, right? How can we do this one? Just go this one, you see, between this one. See, this one, you see, this one, right? Not this one, sorry. Between this one and this one. This one. Okay. Between this one and this one. Right? This one. This one and this one. Right? Because you just set only center, right? This one. You need to set plane as well. Okay, I can do this one by, let's see. Want to add one more. This one is locked, it's already locked, right? You want to add one more, but this one to unlock this one. Unlock. And you can use offset between. You can use plane this one, the plane of this and the plane of the sailing wheel as well. You see, offset between this plane. Let's see. Make sure that this one, this is for this one, and the other one, say for this one. I can use this one. Okay, this bed. So this one also. Okay. Goes this bed as well. Offset one. Becauseมันชนกันนะ Yes. Okay. Okay. And then it change to prismatic jar, you see? Change to prismatic jar. Next, you can check this one. Now, you just use this one. Still one. Okay. Maybe this one. You see. In that case, you see, there are one more over. Okay, sorry, this one. I need to fix this one. I need to fix this one with this one. Fix this one with this one. Okay? I want to fix this one with this one. Okay? So I can do this one by, say, fix together, fix this one, rigid between this and this one, you see, rigid. There are many options, right? Our option will be this one, select this one and this one, both of them, okay? sorry. Digit. Okay. Okay. Let me check this one. Digit. See? 0. 1, 0. Okay. Okay, so add digit between this and this. Okay. One is make this one will not rotate with this one, so you have this one. See this one. Still have crash anyway. See, still have crash here. This component, right? This one. You have to change anyway. This one. Okay, this screw, and don't forget you have digit between this and this one as well.